Hello, in this video, I'm going to be going over what you're supposed to be doing for the stringing test. It's a little bit different than what it has been for the previous homeworks, or at least as you see them in the modules now. But basically, we're going to be using the Cura software to sort of generate this file, and then we're going to print it and sort of analyze what it's doing. It's very simple in terms of actual setup. But sort of the work comes in when you have to analyze what's been printed. Okay, so let's go to Cura. So yeah, unlike everything else where we download from Thingiverse, we're gonna actually use an add-in to print this. So basically, if you go to Marketplace up here, you should be able to install the auto towers. Obviously, I've installed mine already. I've practiced this before making the video. But yeah, you would install the auto towers, okay? And then what you can do is go to extensions and go to auto towers. And we're going to do the React tower. I'm going to tell you to choose the 10 to 50, okay? Because I think that'll give you quite a large range, and hopefully you'll see a range of stringing. And this is your retraction percentage. So you could see how varying degrees of retraction improves the stringing. Okay. So yeah, if you slice that here, really, I'll go over what we're going to use here. You can stick with, really whichever layer height you want. You'll probably get more stringing on a larger layer height. But really, what's important is that you could compare uh, the percentages within the print. Okay, so you could compare the lower levels to the very top levels and so on as it transitions. Okay, so layer height, not super important, but we'll keep everything else, to the line width of zero point 0.4 if you're using the 0.4 millimeter nozzle. I think I explained that in some videos in the past. So you can make the line width whatever your nozzle width is, or your nozzle diameter is, I should say. Yeah. You keep your initial thicknesses, your top and bottom thicknesses. You could keep all that to default. Infill doesn't really matter, as you can see. This is so if I slice this, I could show you that it's just going to be a pretty thin walled guy, and the point is to not make any, there's no infill at all in there. There's just two walls, it looks like. So that doesn't super matter. But normally I like to increase the temperature a little bit for what it does as a default for PLA. So I like to keep it up to 210. And yeah, I like to add a brim. And this will not need any support whatsoever, so I don't need to generate that. All right, so yeah, you can see the preview here. We're looking good. So yeah, very simply, you would just slice this and save it to a disk, print it out, and then write about how the retraction saves the stringing. Okay, I guess I haven't really been descriptive as to what exactly stringing is. Well, basically, as the extruder lays, or sorry, the nozzle lays a bead of material down, it'll be sort of pushing material through the nozzle. All right, the extruder will stop itself. Okay, however, if it just extruded and then stopped, you would have a little bit of material just dripping out of the end of the nozzle, which as it moved rapidly to another position, it would leave a little wispy little string, from one location to the other. Okay, these are usually not that big of a deal, but it's also not desired. And if you can tune your printer to not do that, it's usually preferred. So you could test different retraction percentages. So basically it'll extrude as it's laying down a bead. Then when it's time to stop the bead, it'll retract or pull the material out just a little bit before it goes over to the other side to hopefully prevent some of that, some of that, kind of stringing, I guess, if you will. So yeah, that is all we're doing for this one. It's up to you to analyze your findings and write the report.